In this lecture, we will learn how to create the geometry for the cement kiln. First, what is the first step? You have to create a plane normal to this, and after then in this plane uh, we can we can rotate this one. Just move this plane at an angle. First create this rod in this plane, which has size 3 meter rod, 3 meter, and inside there is also burner circle is there. It may have around size 0.5 meter. 0.5 meter is the burner cylinder rod. We can avoid it. Only one rod is enough just to create the cylinder of the kiln. And then this extrude in other direction, say no more. It can has a length around 40 meter. They click here. Then select this body. Then move. Then rotate at an angle of the then put this point here, rotation point here, put rotation point here. 3 times click, then put this point here. Then click on this axis and put 350, no, generally 3.5. That means 356.5 is the degree. And then click here, select for the center axis and check the angle, this angle and this angle, how much is there, and the entire click button. This angle is 3.5 degree. See, this angle between this is a 3.5 degrees Celsius. This is a cement kiln which has diameter is a 3 meter. That means this is a kiln is there, and this is a kiln, and this is the name of the zone created for this volume. The next step is we have to create a burner. You have to select a plane just inside it. It may be around 1 meter, and select this plane as a sketch plane. Select home. Then we have to create a burner. How much size is a burner? Is a 0.5 meter. And around is there is a thickness is there. We want to model. It may have a 0.5. It may be there. It may have more thickness, 0.6. And after that, we can hide this body. Just close it and click here. And pull from back side, select here no merge. We can select this as meter as a 4 meter length. We can click here and say no merge and click here for the 0.6, and here this body is there. This body we can also put some more distance because you have to subtract it. You can take any distance, 0.8. It should become outside. But next option is you have to subtract body, because next option is delete duplicate body. You have to delete duplicate body. Body. Where is the duplicate body? This is here is there, because this body is this there, and this two body is also there inside. That means there is a overlap body are there. We want to delete it. And how can we can delete? Here option is a split. Then one more body is created. This extra. We can add. We can select as delete. Select all here and put here option is there. Transfer and is there. Here is also one extra body is there, but we can also delete here. We can also split this body. Select this body, then cut by this body. Other option is there. We can reverse this command. We can use this select to body and put in new component. This is as a burner, and we can split this body by using we can delete this body, then this is the body is there. That means extra body will be deleted. This body we also don't want. This can be deleted, and this is the body. This is the body for the cement kiln. We can keep this body. We can put here a suppress for physics. If you want feature, we can keep body. Otherwise, you can suppress this body. Then next, we have to create the rear part of burner. There are two inlet. There are two air inlet, three air inlet, and a single two fuel inlet. We have to model this part in the space claim. Take this plane, section plane, and then we can create this model as a 0.35. We can create this as a size. I think yes. We can take this is how much size is a 0.35. We can take size. We can take no much. We can pull this back side. Is a 0.25 part. we can select as a 1 meter as a length. 1 meter is the size, and what we can select is the this size there. This is a simple burner. We can select what we can select more as a you can take 1.5 meter, 1 meter. Yes. What is next step is take plane here. Take plane here. Take a section plane here. Then we have to create the 2 air inlet, the 2 air inlet, 2 fuel inlet. Because we want to create this model, the simple step is take any line. If you want water, you want to take angle. Uh, we can take any line. This one as a water, you will take angle as a 30. You can take here. No. And this is we can take tab as this 60-degree line. We can take any line if whatever you want. We can take as a uh, take any line. This is a air inlet. This will be fuel inlet. This I take as a fuel inlet. This side angle I will take as a 45 degrees Celsius. This I create a line. Then this is a I here create the this line. Then we have to create a cylinder. This is a cylinder. Just click here and click this point. Then how much long you can go as a 0.2 meter length. And this I will create as a 0.2 meter length. And this is also I take this cylinder 0.1 meter length. And this is I take here from this point this point. This is a 0.2 meter because here this I create this model 2 air inlet. So this is air is also there. Here some air is also supplied here. We can provide here, and we can also create a cylinder here. This is a 0.1 you can take here, this one. This way we can also create possibly. This is a fuel pipe. This base combustion is supplied in both way. And just click here. We can take size whatever you want. This way, burner of the cement kiln is created. See, this way, cement kiln burner is created. It's quite easy. This is the one body is there. This way, Cement Kiln body has been created because this I am enclosure is not considering. I am taking as a very simple model. Look at the transparent. It's a very simple model. This is a very simple model I am taking for the to study the cement kiln. Very simple model. And this is the inlet is there. This is the outlet. Then I select all the body. This all body I put into new component. Is a cement kiln. And then I also said here, put here option I put as a share. Then I can see the connection between all the spaces. Then after that, I move for the workbench. Click here. This is okay. Now here put all body in the single component. This is a burner is there. After that, here flame will be found here. Here will become this side. Fuel will come this side. There is a fuel 1 and this is fuel 2. There are 2 inlet. There are 3 air inlet. They will mix here and then flame will be from here. Then save as project. For the geometry of the cement kiln, we can save. Cement 2022. That means geometry has been created. Next step is to create the mesh. Then click here, mesh. Then select this one. And then drag here. Then click here, drag here, click this arrow and then click on here. Then the geometry will be updated here. It will open in the meshing platform. Here you can see this is the model for the cement kiln. This contact is there. I will delete it. Mesh is there. But mesh size will be very high. I am taking this is as a section plane here because I want conformal mesh. Move this plane here. Then split this body with this one. Then this here create update resource. The body will be updated. Then go to mesh. Select here the ANSYS mechanical. Please note this select here is select for the CFD. Put a CFD and maximum size. See, this is a in mm. I will keep a unit sizing. Here make surface sizing, contact sizing. Uh, Here unit will be there. You can select here units. I take in meter only, so that it will be easy. And what is the maximum size is there? Who can take? You can take as 1 meter as the maximum size. It is also you can take 1 centimeter. Unit is also 1 meter. And here you can select right click on this sizing. You can give as one because we can give maximum one. Similarly, here we can give sizing. We can also give as a, this is also give as a 0.75. And for this one, this body, it has a 4 meter, and we can give as a sizing as a 0.5. And for this case, we can give a sizing. It has a so here guys, so you can give 0.25. Then next is that you have to create a surface sizing. Because it has a size, you can select this surface, this surface, this surface, this surface. You can select this sizing, face sizing is 0.05. 0.05 you can select, and then create the machine for this one. Right click, generate for this generate body. It will be very big because we don't want to. I think it should be less than 0.25. Check it how it will go like it. Means its size is like this one. How much size is there? 54,000 size is there. That's okay. We can because we can create a mesh for this one. But this size is also not okay. Then we have to also give the size is very small. One then we can create the sign generate mesh on selected body. But this is a unstructured mesh. Why it is created? Right click, head body. Because here body is not structured. Hence here body is because not uniform. Hence we can click here plane, then move toward the slide because these bodies are not uniform. Hence unstructured mesh is created. We can move here, the split body. We can put here. We can put this body split here. And we can combine these two body so that structure mesh will be avoided. Then update geometry from the source. First, give sizing. Is sizing given? This height body, height body. Sizing given. This sizing we have to give on this one. This we can create body, show all body. Face sizing, I think it has to miss. We can give face sizing generally to this body. Give face sizing to this one. Then create the mesh. This sizing I think is also far bigger. We can take point two. Okay, right click here, generate mesh. Then next is the click here and generate mesh. This is the height body. We think structure mesh is created here. Yeah, this is show the clear generated mesh. We can put this sizing. Put here we put method. Method you put as a multi-zone automatic control. You can generate mesh on this body. The next mesh is generated. But I think this size is also not okay. But we can select the sizing. I think half of this size. And then clear mesh on this body. And generate one on selected body. This way, X mesh is created. So what is the total cell count is there? Is 1 lakh cell count is there. And generate mesh on this body. Then the mesh is created. What is the total cell count? That means mesh is created, but not so good. Mesh is created, but that is not so good. Then we can click here. Sorry, clear generated mesh. Yes. We can take a smaller body. We can give the face sizing. We can take this one size. Clear mesh on this body. Then I can click generate mesh on this body. Generate. Then click on this body. Generate mesh on selected body. Then okay, mesh is created now. I think this mesh is okay. But if you think this mesh is not okay, but how much size is there? This is a 2 lakh. We can say clear mesh on generated body. This then this one body, which body is selected. Show the version. You can see the smaller size. Then click clear mesh on this our body. Clear generate mesh on selected body. The mesh is created. I think it is fine. It is enough fine. Then click on this body. Generate mesh on this body. The thing like that means enough mesh is created. And then click on this body, then say generate mesh. But that mesh quality is not good. Clear mesh on generator body. I clear point 2. This should be small. Then generate mesh on this way. How much is size there? This is 5 lakh cell is there, but okay. But we also want more fine mesh than need. You can clear this mesh. This I can take this as 1. Then we see how much size will be created. Because this is a very important part. Yes, we want to find mesh. We see how much size is there. 4,93,000. That's okay. That means this mesh we can import in ANSYS meshing platform. These two burners are there. Then we have to give name. This to select as the name selection. Fluid. This is a kiln rotor. This is a kiln rotor. This can give name as a fluid burner. Give as a burner. Then click here. First give air inlet. Give inlet. Click here. Inlet air 3. This is the inlet air 3. Inlet air 2. The name will be up inlet air 3, inlet 2, and this is the inlet air 1, and this is the inlet fuel 1, means primary fuel 1. This is the inlet fuel 2. That means this way I have given all the name. This is outlet of kiln. This is the outlet of kiln. Outlet of kiln is there, and this is the inlet here to the kiln. This way, we have created all the model, and you have to give wall of the kiln, and this is the wall of the kiln. This is called a rotor because it should be in rotation. This way, we have created a name. This is a fluid kiln. This is a rotor is there. That means we can put the setting here. We can put reset layout, and this way, this is cement kiln is there. The burner fluid, and this is a burner. This is a give name properly. Here inlet 2, inlet 3, fuel 1, fuel 2, outlet, inlet of predator, wall of kiln. Then mesh is okay. Then mesh is okay. Then we can export. You can save the project. Project is saved. Export and mesh. Then we can run this model. Q path as a cement kiln model. Once it is over, then open the ANSYS FLUENT. You path of the because this file is saved here. This is the cement kiln file is saved. Give this path because this file path I have to give here. If you once you give this path here, then you can upload this file. These are the files are there. You can open in this 3D, double precision and single processor. Put here key viewer changes. Put here read mesh file cement kiln. Then file it will be read properly. There will be some interfaces there that you can delete. Save project. We can export the mesh file. and then overwrite this file. Then you can read the mesh file again. This way you can see these are the inlet. What we can see in the meshing file. This is the outlet. Yes, we can see the model here. This is the model is there. Here outlet is looking here. See, this is the model is there. Because this is the air inlet is there. This is the air inlet. This is the air inlet 1. This is 2 and this is 3. These 3 air inlet are here. These 2 fuel inlet are here. Primary air. And this and the secondary is here. This is the burner is there. Burner. This is a burner. This is a cement kiln. And this is the outlet. We want to model this and this is a rotor valve. Please note that this is a rotor valve. We can give it rotation. Okay, then you can check the size. You can check the mesh quality. Mesh quality is also fine. Then this is a model is there. Then you can model. This is a cement kiln. This is a burner. These are 2 air inlet and 2 fuel inlet. How to do setup in ANSYS FLUENT? First also check the mesh size. Also check mesh quality. Mesh quality is 0.467. This is good. Mesh size is a 2.7 lakh cell. Just click here. Then you can check mesh quality. And this other option is also there to carry out mesh checking. Mesh checking means there is one inlet, there is outlet. For simulation, there should be at least inlet and outlet. Go in general. Click here on steady state. Because we have to solve simulation in 2 steps. First is steady state. Then after running it, then give rotation to the cement kiln. That means simulation will be transient. Then you can run a simulation in 2 cases. Go to model. Click on energy equation. Then select in case realizable model. can select any turbulence model, case plan model, realizable, standard wall function. Keep this model constant as it is. We can select radiation model, a DO model, then resolution for theta, resolution for phi. Then go to species transport. You can select this mixture model, select volumetric reaction, and this is the TCA model, turbulent chemistry interaction model. And this is the coal calculator. We can define data based on proximate analysis, ultimate analysis by using this composition, carbon, hydrogen, oxygen, nitrogen. Stoichiometric reaction coefficients are defined. We can select two-step reaction. We can define high calorific value of coal and some other constant. This is the gas phase reaction of the coal. This is applicable for the coal because coal react with here oxygen, and then we get carbon monoxide, H2O, and plus nitrogen and some oxygen, then we get CO2 finally. But some model constant of this reaction depends on the fuel composition and the molar balance from the both sides. This is a reactant, this is the products of combustion, but final product of combustion will be CO2 and water vapor. We can select the coal particle as a combusting from inlet, because this we are providing some coal particle and which come in contact with oxygen and we get product of combustion. We can define diameter of particle, temperature, velocity and mass flow rate. We can define mass flow rate of the air, turbulent intensity, viscosity ratio. We can define air temperature as 420 Kelvin. Here we can define the oxygen as a 23% in air. This is the mass fraction of the O2 on mass basis. This is a mass basis. For the fuel, we are not defining any other quantity. Volatile matter we are assuming to be as 0 because volatile matter come from the devolatilization process. Here we can select simple algorithm, second order scheme for the pressure and momentum, and other variable we are keeping for second order affluent scheme. This is the warp phase gradient correction. That means wall fluxes will be corrected. These are the relaxation factor. But you can initialize and then run with equation. You can run this for a certain number of iterations. Just run it for the certain number of iterations. Here, mass, momentum, energy, turbulence, intensity, and this species transport equation are being solved. After simulation, you can check the result. I checked already simulated case file. And we just check the how much iteration have been solved. After solving this iteration, that means around 600 iterations have been completed. Then you can check the result. For the temperature, here you can check temperature in Celsius or Fahrenheit, whatever you want. After combustion, you can see this is high temperature gases due to combustion of the coal. And this is the burner. Here air enters from this end. This air enters here and fuel enter from opposite. And here mixing happen and mixture enter here. And due to reaction, temperature increases significantly high. Who can check velocity control? Here you can see high velocity jet of the burned gases from the cement kiln. And these high temperature gases interact with cement kiln mixture, which flows in opposite direction. This way we can do combustion modeling of cement kiln burner. For more detail, you can visit website for combustion and emission. and click on CFD Modeling of Cement Kiln. Here we can get process in cement kiln, burner of cement kiln, reaction, details of combustion modeling for cement kiln and cement bonding. Because cement kiln burner consists of the long fire gun. And these reactions are happening inside the cement kiln. Please note that these are the reaction of calcination occur in cement kiln. This decompose into the calcium oxide and carbon dioxide. There are three reaction zones: decomposition zone, transition zone, and sintering zone. And these are temperature ranges for the reaction zone. These are governing equation: mass, momentum, turbulence equation, enthalpy transport equation. For DPM, this equation is being solved. Rate of change of momentum of particle is equal to drag force and sum of other forces. These are steps followed for CFD modeling. First is pre-processing, second is simulation, third is post-processing. And this is the temperature plot along the axis of the cement kiln from the exit of the burner. Temperature decreases as the distance from burner increases. Thank you for watching this video.